So today we'll see how to solve a particular problem when a beam is subjected to more than two or three forces, and how the application of moment helps to determine the unknown force or determine the resultant as well as the resultant of the forces as well as the application of the resultant on the particular location. Now consider a weightless beam, and there are four forces acting on the beam at point A, B, C and D. The magnitude of the four forces are 10 Newton, 4 Newton, 8 Newton and 12 Newton respectively. The forces are acting at an angle of 45 degrees, 30 degrees, 30 degrees and 60 degrees on the beam. The total length of the beam is 3 meters. Now I am going to resolve all the four forces into its horizontal and vertical components. So resolving the force P acting at point A, you get 10 cos 45 acting towards the left and 10 sin 45 acting upwards. Similarly, at point B, if we resolve it into horizontal and vertical components, 4 cos 30 towards left and 4 sin 30 acting downwards. Similarly, the point C, I am resolving the force into two components. 8 sin 30 acting vertically downwards and 8 cos 30 acting towards the right. Now next the last force, that is 12 Newton force, 12 cos 30 acting towards right and 12 sin 30 sin 60 acting upwards. Now I have resolved all the four forces into its horizontal and vertical components. Now what I am going to do is I am going to apply the conditions of equilibrium. So what are the conditions of equilibrium? Sum of the horizontal component of all the forces is equal to 0. Sum of the vertical components of all the forces equal to 0. And then we have to find sum of the moments of all the forces at a particular point equated to 0. So these are the three conditions of equilibrium. So first I am applying sigma h. So sum of all the horizontal component of all the forces. So for the first force, it is minus 10 cos 45 since it is acting towards left. Then minus 4 cos 30 acting towards left. Plus 8 cos 30 acting towards right. And plus 12 cos 60 acting towards right. So the sum of all the horizontal component comes to be 2.39 Newton. Similarly, I am going to determine the sum of all the vertical components. So which is 10 sin 45 acting upwards. So plus minus 4 sin 30 since it is acting downwards, minus 8 sin 30 since again it's acting downwards, plus 12 sin 60 since it is acting upwards. So now the sum of all the vertical component is found to be 11.463 Newton. Now sigma V and sigma H are drawn to the coordinate axis. Now I am finding the resultant of all the forces, which is nothing but square root of sigma H the whole square plus sigma V the whole square, which is coming to be square root of 137.126. Now the angle alpha is nothing but tan inverse of 11.463 by 2.393, which comes to be 79.2 degrees. Now the sum of all the horizontal and vertical components have been found and the direction is also found. Since both are positive, the resultant force is going to be acting at an angle of 78.2 degrees. Now we have to find the location of the resultant. So in order to find the location of the resultant, now the resultant is acting at a particular point on the beam and its magnitude is 11.7 Newton and it's acting at an angle of 78.2 degrees. So now we want to find the location of the resultant on this weightless rod AD. Now the point at which the resultant crosses the rod. So that point, from that point to point A, the distance is taken as x. The distance is taken as x. And the force can be transferred along its line of action to any point. So the force is brought over here, and that point M. From point A, the perpendicular distance is taken as z. Now, I am finding the sum of the moments of all the forces about point A. So which is nothing but 4 sin 30 into 1 and 8 sin 30 into 2 plus 12 sin 60 into 3. So in this particular book, they have taken clockwise as positive and anti-clockwise as negative. But naturally, what we do is we take counterclockwise as positive and clockwise is negative. So the answer is going to be 21.76 Newton meter in the anti-clockwise direction. So that is the sum of the moments of all the forces. Now moment of the resultant. So moment of the resultant. So the vertical component of the resultant, because the horizontal component of the resultant is not going to produce any moment because it is acting on the same line of action. So the vertical component of the moment. So 11.71 into sine 78.2 into x, which is again going to be a clockwise moment, is equal to 21.76. So from that we can find the horizontal distance x. Now similarly, we can directly find the perpendicular distance z also. That is 11.7 into z is equal to, this is going to be producing a clockwise moment, is equal to 21.716. From that the distance z can also be found. So x and z both can be found using this method. So this problem gives a clear idea how to convert a single all the forces acting on the beam into a single force, and using the moment concept how you can determine the location of the resultant also. Thank you.